All right, in front of us are very common electronic devices. Okay? So ang uban ani is very familiar to us, sa may not be, no? Siguro sa kagamay sa kuan sa image. Pero of course, ang akong gusto i-point out is na something in common ani nila tanan. No? So what devices are these man in front of us? We have the cell phones, na Apple, na Samsung, na laptop, no, na Core i9, na car, no, sakyanan. Right now, automobiles or cars are not considered anymore as purely mechanical or electrical machines, but di lang pud gani kay electronic, no? But I think almost all modern vehicles today are equipped with onboard computers, no? Or kundi mo siguro computer, gyud kay when you say computer, basta nga nasa una is PC, but it's equipped with onboard microprocessors or microcontrollers. No? Kay Apple Watch, no? Kaning sa tungaon sa man ni sila. Familiar?
Motherboard?
Oh,
Sorry, sir.
Arduino, okay. Development boards, no, na Arduino, na Raspberry Pi. No? Naputay discrete nga electronics, kaning nasa center right. Okay. The fire alarm system, nasa bottom center left is radio communication equipment. Kaning na Korean diri, unsa gani among gikuanan ni before. I think smart closet man siguro ni or fridge. Then naputay toaster. Oh. So ang something in common na tanan kay of course they are made up of they're within them nasa mga electronic devices, no? But more than that, they are all what we call as electronic systems. Okay? Electronic system na sila. Even though ang uban ani kay nay mga mechanical nga parts, pero electronic systems nonetheless. Okay? So karon ato mag-establish ta og mag sort of general model on how we will define electronic systems. We could na may two ways on how to study electronics. Okay? Pwede bottom-up approach, pwede po top to bottom. So when we say bottom-up approach, we'll be utilizing both of these approaches as we progress to the semester, ha. Na times mag bottom-up ta, na po times nga top-down, no? So when you say systems approach, it's a top-down approach, so gusto sa taas. So dapat natin model ana. So the systems approach sees everything as a system, no? Natay system and na inputs and outputs. Okay? So tanan ani masing asa pa ani nga device, whether it could be the cell phone or the electronic toaster or smart toaster, no? I think this is an IoT toaster, no? Internet of Things toaster na siya. Or whether the fire alarm system bakaha, no? Or the car, it could be thought of as a system, no? With inputs and outputs. Okay? So example, the cell phone, no? The cell phone in itself is a system, and it is also a system of systems. May mga parts ana niya sa cellphone nato that we could consider as by themselves system. A system by themselves already a system, no? Example, the part of the battery nga the part of the cellphone nga ga-handle anang power nga matters, di ba, ang battery, no? And battery and the accompanying circuits nga mag nga appeal diha sa pag supply power sa cellphone. So kato mismo the power power supply system sa cellphone, no? So system gyapon nagyapon yung mga inputs and outputs. Ang touch screen, no? Touch screen sa tong cellphone, the touch screen in itself or the screen is a system. The touch screen together with its accompanying circuits gyapon, no? So what are the inputs? Pwede nga atong pag push, no? Pag push, pag slide mo ng mga input. Or energy wise or signal wise, those are mechanical inputs, no? Pag push, pag slide, yan na. Pag touch kibali sa screen. And ang output ana, ang input kibali nga push ug touch ug slide, they will be converted by the touch screen system into electrical signal. Okay? So ang output ana is electrical. If appeal sa touch screen system ay ang atong microprocessor, okay? So ang output ana is not only electrical but also light. Okay, convert mo to niya katong imong gi-input sa iya nga touch into something visually makita nato sa screen. So yan na, no? May input ug may output. So that's for the cell phone. Actually, that's for the touch screen system lang sa cellphone. So mas asa ani nga mga devices, pwede gid nato ma-simplify into this one, a system, no? So this is although very simple, but very useful, no? A tool for us to learn. Actually, not only electronics, no, but all engineering subjects, no, in general. Pwede natin may magamit. Di naman siguro niya sa electronics engineering ma-apply or dili lang siguro ganyan niya sa electronics one ma-apply ang systems approach. Pwede magyapon na yun na ma-apply sa bisan nun sa nga subject nandun atong ginatunan, no? So fire alarm system, pwede gyapon na siya inputs and outputs. Ang well, of course, a microprocessor, pwede gyapon siya ma-simplify as ani nga system. All the more nga simplified ang input, digital input and digital outputs. Digital electrical inputs o digital electrical outputs naman ang input-output sa atong Core i9 nga microprocessor. So the point is, maski unsa pa na nga device, no, maski unsa pa nga machine or system, pwede na to siya ma-simplify as ani. Then later na lang dayon na nato ipang dissect para mas more pa nato ma-analyze ang isa ka particular system. So one important concept put here to understand is the system boundary, no? It defines kung unsa gyud specifically ang pwede mabuhat sa tong system. Now consider this one sa screen, no? We have the microphone, amplifier and speaker system. So depende kung asa nato giset atong system boundary for the purpose of studying an audio system. If gidefine nato tong boundary as appeal gyud ang microphone ug speaker sa sulod, so meaning ang input is sound and ang output is sound sad, no? Kaya appeal man ang microphone ug speaker sa sulod sa atong system, no? But if we define the system boundary nga ang kuan lang gyud ang audio amplifier lang alone, so dili appeal sa system nato ang microphone, dili pud appeal sa system ang speaker, although assumingly i-connect man gid nato ang microphone ug speaker sa atong kana nga amplifier system. So the input then becomes electrical signal and also with the output electrical signals gyapon. So depende, no? Depende sa atong aim, depende sa atong objective kung asa nato iset ang atong system boundary. Okay? Kay the same di ba? The same din nga system. Pero tungod kay gi-focus sa second nga part, gi-focus na to atong system as only kanang composed of the amplifier. So yang input output kay pure for the electrical, no? So kani general man yung system, no? What about electronic system? Okay? So man yung mga input ug output. Kaning sa middle nga part, kani siya, no? Mo ning atong electronic system. Okay? So ang input nga portion is specifically ato na ginatawag og source, no? Whatever is that thing, no? Thing or device or even maybe system gyapon ni in itself, nga ato i-connect sa input portion sa tong system in question is what we call the source. And sa output, kung whatever device and system pod nga itong i-connect sa output na portion is what we call the load. But I guess that's already known, no? Kabalo naman siguro taana. Okay, even sa circuits before, umana itong mga terminologies nga gigamit. Now, sa electronic systems in particular, most of the devices nga gina-consider as the sources are what we call sensors, no? And ang mga load na ibutang sa atong electronic system are what we call actuators, no? Sensors and actuators are both generally called as transducers, okay? So sa kuan, in the context of electronics, when we say transducers, those are devices that convert energy from one form to another. Okay? Ganahan transducers kay i-convert niya ang energy from one form to another. So ang sensor is i-convert niya ang energy from one form to electrical. Okay? Ang output permis sa sensor is electrical. Okay? So the same with the actuator. Ang input sa actuator is always electrical. Ang output is, well, depende na dayon kung sa siyang klaseng actuator. No? So for example, sound sensors and sound actuators, kani sila, si microphone o si speaker. Si microphone is a sound sensor. No? Ang atong consider ganing ang microphone is katulad ganing small nga electronic part sa sulod sa kanang microphone nga atong ginahawiran every time what video kita, di ba? So kanang di nato na makita ang microphone nga piyesa sa sulod ana niya, muna siya ang atong ginatawag nga microphone sensor. Okay? So it converts sound pressure or sound, no, into electrical signal. Okay? Then i-process na siya sa atong electronic system, i-manipulate ba niya or whatever. Example kaning atong electronic system is a reverb, no, reverb na system. What's another term for reverb? Reverberation. Di ba mo nang mag-echo? Kanang usahay appealing man na sa mga video key system nga mag-ipa-echo ang kon, di ba? So muna siya, no? That's an example of an electronic system kanang the circuit is capable of producing reverberation gikan sa sound, no? So para ma-manipulate niya tong sound, i-convert sa sensor o i-convert sa microphone ang sound into electrical, and then i-process to sa circuit or system ang electrical signal, then i-output niya. Dito niya i-feed sa load, which is in this case the speaker. Okay? So sa second portion kaning sa bottom nga part, so ganina atong giingon nga pwede gyud nga kita mag-define unsa ang description sa atong system. So kani our system is composed of, or kani nga system is a system of systems composed of three cascaded systems, no? So we have subsystem A, subsystem B, and subsystem C. Consider subsystem A. Si subsystem A, iyang load, or I mean, iyang source is si sensor. Okay? Magbalilag ni ay. Okay, bale. Si subsystem A, iyang source si sensor, no? Iyang load is si subsystem B. Okay? So, yan na ang concept when we connect or when we cascade systems. The next nga system is will become the load of the previous system. So si system B now becomes the load of system A. And the same with system C. Si system C ang load ni system B. So si system B now ang source ni system C, and so on and so forth. Okay, because ang system boundary na to is dili man nagsugod, no? Yan na. Okay. So focus lang dili karon sa kaning middle nga portion, kaning electronic system. How do we define the I? What is an electronic system as compared to other types of systems, like for example a mechanical system or an electrical system, no? How do we differentiate an electronic circuit from a purely electrical circuit? Because I'm sure naka-study naman taog electrical circuits, diba? Circuits 1. So paano ba ito ba difference karon sa electrical circuit o electronic circuit, no? Na ba dire? Okay. So, kani the study of electronics. Or basi na mo yung idea how paano man unsa may kalahian sa isa ka purely electrical circuit o electronic na circuit. Kinsay gusto mag
Guess lang, sir.
Sige, guess daw, Josh.
Sir, ang electronic nga mga system, sir, kay kasagara kay naagi coding, sir. Like
Coding.
naagi data. Oh, yes, sir. Ang electrical, sir, kay more on kon naman gud siya, sir. Wala kayo'y coding
Signal.
of data, sir. Oh.
Signal of power, no?
Oh, ana lang, sir. Ang sa electronics kay naagi coding, sir. May codes.
A good observation, no? Sakto man gyapon na Josh. Well, pero kulang gyapon. So sakto man na nga observation nga ang mga electronic circuit is ga-involve og data, di ba? But that's not to say nga ang electrical systems kay dili capable of manipulating data. Makaya man gyapon, di lang conventional. Pero naapo yung mga electronic systems man nga dili necessarily ga deal with data or mga coding, no? So common lang noon sa mga electronic devices or electronic circuits nga ga-handle og data and codes. Pa dili man noon tanan. So napag yung marag determinant or main nga difference ang isa ka electrical o electronic na circuit, no? So, well, thank you Josh sa imong response. Napay gusto mag-try?
Ako, sir.
Sige daw, French. Ikaw na yung French, no?
Adi, sir, Dayan.
Adi, day. Asa, wala nang gitanawang ko mo good. Kinsa ni asa I speak. Asa nga asa yung name di ay
Dayan, sir.
Dayan. Si Dayan. Okay,
yes, sir.
Sige daw, Dayan.
Isa ka major difference sila, sir, is that kanang ang electrical is nakay data madawatan and then like syncables na sila data ga kadawatan. However, sa electronic bitaw, sir, kay murag gina-process niya ang data tas na day murag response, murag corresponding response nga imong gi-assign ana nga device.
So naay kakita mga processing then apoy mugos nga response. Pero ang mga electrical system ug mechanical systems wala ba dayang ana?
Pero murag kuan kanang ga-involve lang gyud siya kanang electronic components.
Very good. So ako nang kwaon nga na term electronic component, no? So sige, thank you bitaw Dayan sa imong response. So naka-mention si Dayan og electronic component. So kana muna siya ang difference sa electrical system og electronic or electrical circuits ug electronic circuits. Na mga specific electronic components nga kung naana siya sa isa ka electrical circuit, mahimo na dayon nag-electronic circuit. Okay? So whatever these electronic components may be, muna sila maka-make of difference. So akong i-kuan nga sa screen what these electronic components are. Okay? So these make up electrical circuits. We have discrete passive components and circuits. Okay, we have resistors, capacitors, transformers, inductors, crystal oscillators man siya. And we have circuits, no? Electrical circuits, RLC circuit, no? RC, RL. Yan na. Kani are examples of transducers, not necessarily electronic components per se. Some of them may be electronic in nature but not all, no? So man itong giyon ganiha nga sensors. These are input devices. O kana ganing switches and keyboard are mechanical man na sila. Mechanical devices man ang switch and keyboard. So if ato tong kwaon tong definition ganina, these input devices convert a physical energy into electrical, no? Pwede sound, pwede light, pwede mechanical like force, pwede heat, convert niya into electrical. And bali po na, these are our actuators, no? Converting electrical energy into, or electrical signal into another physical nga energy. Speaker, electrical to sound, the same with buzzer. Solenoid, electrical to motion, no? Force magyapon na siya. The same with DC motor. LED, electrical to light. LCD, no? Antenna, electrical to electromagnetic. So these are common examples of actuators. Okay? So kanina dayon tong atong na mention ganina na electronic components, starting with the diodes, the transistors, the thyristors, okay? Integrated circuits. Although integrated circuits are composed of thousands or millions of not only transistors but maybe na naman mga resistors daan pod inside these integrated circuits. But nonetheless, they are made up of semiconductor devices. Discrete electronic circuits. Okay, so these are discrete electronic circuits: the half-wave rectifiers, full-wave rectifier, amplifiers, oscillators, mixers, modulators, voltage multipliers, ligators, and etc. Ang atong modern electronic systems, in one form or another, kay nagyud nila ani, no? May mga rectifiers, amplifiers, oscillators, no? Atong modern electronic communication system like radios, no? Sa sulod sa cellphone, no, nagyud na yung mga oscillators and modulators and amplifiers, no? Basta kay electronic system siya or electronic nga gadget na lang day system din. But when we say electronic gadget or electronic device, ang gadget na lang ay paano kayong electronic device mga general electronic gadget, no, na atong gina-use atong daily life, nagi na sila ani, no? Sila aning kaning mga devices kana sa atong screen. Whether discrete or integrated. Okay? Kani digital circuits. So katong giingon ni Josh ganina nga capable of coding and storing and manipulating data kung nana sila ingani, no, nanay mga logic gates and flip-flops and DRAMs, no, and counters and timers and processors, shift registers, etc. So namang kani, no, kani siya kani nga mga electronic systems. These are examples of systems nga pwede dai gyapon electronic device nga dili yun necessarily mag-handle og data. Okay, for example, plain lang siyang amplifier, no? Plain amplifier system. Dili man necessarily nga handle gid siya og data or codes. Pero ayan na. Pero sakto to, electronic circuits are very much capable of handling data gid, no? Through logic gates and digital circuits, no? Kaning nasa atong screen. So these are some examples of electronic tools and equipment more commonly found in the electronics laboratory. Multimeters, common man no? I think nakaagi na taan yun sa ning how multimeters work, function generators. But one staple na electronic test equipment yun, hindi dapat mawala sa isa ka electronics laboratory is this one, the oscilloscope. Very powerful tool which allows us to view waveforms, no? Oscilloscopes. So all of this all of those devices kaniya atong nakuan will go into the modern electronic devices that we have now. No? Computers, robots, mystery gadgets, data loggers, sensors, etc. And all of these devices. Okay? Ito. So that's an overview of the field, no? The field of electronics engineering. But sa atong subject, I think mas mag-focus lang ta dire, kani. Diodes and transistors, no? So, gabi ba isa ka semester natong tun-an, kanila diodes and transistors. Because true enough, each one of these major categories kay isa man pud na ka subject sa amo sa ECE. Okay. Kani siya summary. Okay. Some questions to ponder. Okay, based atong discuss today. So kung lang siguro basa ani ako man i-upload sa e-learn, no? So that's that. Question so far.
Wala pa, sir. Okay pa, sir.
Apa, sabdan pa man pod, no?
Wala pa may solving, sir.
Lapay solving. So more na inyong gi kabalak-an na solving na. Gamay naman atong solving. Ito kay kanang timing na sad biya nga nauna ang inyong circuits kaysa sa electronics because isa sa prerequisite sa atong kaning subject is at least a basic understanding of electrical circuit theory, no? KCL, KVL, nodal, mesh sometimes. Ako di ko gagamit og mesh. Ako mga students last semester ganahan gid sila mesh para lang big answer na obtain. So, well, whatever works, no? Thevenin kana. Isa sa important gyapon nga concept na naa sa circuit theory is Thevenin equivalent circuit. Magamit gyapon nato na. So all those topics inyong na discuss sa circuits 1, gamit ato to dire. Electronics 1. Inyo ganing kaning subject, no, electronics 1 is compressed. Ako man mention last week mo pud day, no. Compressed siya nga electronics 1 and 2 sa ECE. No? So we'll try to cover as much topics as for half the time. No?